Now, we have a variety of different approximations for different cases. The electric field of a long rod on the line bisecting the center of it, the electric field of a ring in the XY, around the origin in the XY plane, looking at it at some point Z, the electric field of a disk centered on the origin in the XY plane, and we're looking at it at some position D, and the electric field of an infinite plane of charge that we're looking at some distance. Now, I want to take and extrapolate this out. What happens if the distances become very, very large? Well, let's look at these for specific cases. In this case, the electric field for an infinite line of charge, you would think, well, uh-oh, that means infinite charge. And we're obviously not going to have that, but if we're really close to a long line of charge, then we can say, call it infinite, and we're not losing, there's some rounding error, but some approximation error, but if it's small enough, who cares? It'll make life easier. Because if L over 2, if it's very, very long, L over 2 becomes huge compared to R. So this R squared plus L over 2 squared becomes basically L over 2 squared. And so the electric field is given by K times 2Q over L, or 2 times the line charge density times K. Now, for these cases, as Z gets huge for each one of these cases, then, in that case, the electric field goes to, well, Z squared plus R squared becomes basically Z squared, if Z is huge enough. So this is Z squared to the 3/2, or Z cubed. Z over Z cubed is Z squared, which is cool, because that's the electric field of a point charge. And the same thing will happen here. In each of these cases, we'll get an electric field equal to, well, let's see, if Z is huge, then I've got eta over 2 epsilon naught, to use the most compact writing of this, times 1 minus Z over, well, that's Z, the square root of Z squared, or Z. Which, let me double check. Right? 1 minus that. At a very great distance, this should also break down into the net charge, which here will be Q divided by the area times 2 epsilon naught times the term in brackets. And since that ring is pi r cubed, here this is going to break down. Obviously, if I just let that go to ridiculously huge numbers, that's going to be 1 minus 1, or 0. So we're going to lose accuracy there. So what we need to do is use an approximating series. And you can actually look that up in your Calculus 1 book. It will work out in the same way. It will come to, hey, just treating it as a point charge at a very great distance.